Good day. We are here again today to continue from where we stopped our lectures. And today we'll be looking at variation. And I'm still Mr. Jeremiah Ajali. I hope you are taking time out to study and to prepare for your exams because preparation it's key to success. Our target still remains on how you can get above 300 in your Jamb. So that is what we are focusing on. So today we'll be looking at variation, and I want you to say after me before we start. As I study today, I commit my ways to the Lord. My plans are established. I am blessed. My memory is blessed. Jesus Christ is Lord and Savior in my life. I have wisdom and understanding from Him. Amen. Okay, so variation changes as things changes as they vary. Okay, we have four types of variation in mathematics. We have direct variation, we have indirect variation, also called inverse variation. Then we have joint variation, and the fourth is partial. We have partial variation. Okay, we'll be considering these four of them. If you know these four types of variation, you can solve any variation equation: direct variation, indirect variation, joint, and partial variation. Okay, so let's take the first, direct variation. Direct. Okay, for direct variation, if you have a quantity s varying directly as y, this is how we represent it. S varying directly as y, this is your varying sign. S varies directly as y. What it simply means is that if you increase s, if there is an increase in the value of s, there will be a corresponding increase in the value of y. And if there is decrease in the value of s, there will be a corresponding decrease in the value of y. It is direct. If it increases here, it increases here. If it decreases here, it decreases here. That's what makes it direct variation. Okay, now let's take questions under direct variation. It says if s varies directly as y square and s equals to 2 when y equals to 1, find s when y equals to 3. Okay, so s varies directly as y squared. Okay, if we put our constant of proportionality, it becomes s equals to constant, let's call it k, y squared. Okay, now when x is 2, y is 1. So when x is 2, y is 1. So this is 2 k, y 1. Put 1 here, you have 1 squared. And you see that 2 is equal to 1 squared is 1 times k, gives you k, meaning that our constant of proportionality k is 2. Okay, now if our constant of proportionality k is 2, if we substitute it into this, we'll be having s to be equal to, in place of k now you can put 2y squared. This is called the relationship. Okay, we'll call this the relationship because at times you might be told to get the relationship for the variation. Okay, with this relationship we can get corresponding values of s when y is given and corresponding values of y when s is given. Okay, like the question is asking us to find s when y is 3. So when y is 3, we put it here. It means that s will be equal to 2 times 3 squared because y now is 3. So s is equal to 2 times 3 squared is what? 9, and 2 times 9, 18. Meaning that s is 18 when y is 3. Okay, now I know we are dealing with Jamb, so we have to look for means to buy time. I'll be introducing you to faster methods so that it will be easier for us as we proceed. This same expression, s varying directly as y squared, meaning that s is equal to ky squared, that the constant k, make k solid of formula, is going to give us s over y squared. Okay, if this constant is true at any time, it means that s1 over y1 squared is equal to s2 over y2 squared. For the first instance, the constant will be true for the second instance, and for the third and for the fourth, as the case might be. So s1 over y1 squared is equal to this and that. So we substitute the first case of s. We're given that when s is 2, y is 1 in this case. Then for the second case, we're looking for s when y is 3. So you just do the direct substitution and you still get the same answer. This is direct. You just get it directly. Okay, so putting x here, you have 2 over 1 square is equal to x over 3, because y is 3 now, squared. 1 squared is 1, this is 9, so it will be 2 times 9 is equal to x, meaning that x is equal to 18. Okay, so this goes directly to giving you the answer by cutting the relationship. But if you are given a question and you are demanded to get the relationship, you must pass through the first method, which is method 1, to get the relationship. Okay, next question. We'll be using both methods for now, so you can understand it better. It says if n varies directly as m and n equals to 8 when m equals to 20, find m when n equals to 7. Okay, don't forget you have to pause at various times, take down the question, solve along. Don't just spectate, participate. Don't be a spectator, participate. That's the way to learn. You have to join up to engage in what we're doing here. Okay, now if you look critically, we're told that n varies directly, so this tells us it's a direct variation. So n varies directly as m, direct variation, because of that word directly. And it means n now is equal to, putting equal to, changing proportional to equal to, a constant is introduced, and m. Okay, when n is 8, m is 20. So we can use this to get the constant k, meaning that 8 is equal to 20k. So k is equal to 20, 8 over 20. K is equal to 8 over 20. 4 here, it's 2. 4 here is 5. So k is equal to 2 over 5. So the relationship, we'll now be introducing k here. N is equal to 2 over 5 m. This is the relationship. Okay, this is the relationship. Now the question is now asking us to get m when n is 7. Okay, so we'll put 7 for n is equal to 2m over 5. Cross multiply. 35 is equal to 2m, meaning that m is equal to 35 over 2. Okay, is equal to 35 over 2. Now we can also use the second expression. If this is k, meaning that k is equal to n over m, making k solve the formula from here. K is equal to n over m, meaning is equal to n1 over m1 is equal to n2 over m2. So for the first case, which is the m1 case, when n is 8, m is 20, so put that there. 8 over 20 is equal to, for the second case, when n is 7, m is what we're looking for. Okay, so m simply will now be cross multiply 20 times 7 divided by 8. Okay, 2 here, 4 here, 2, 4 here, 5. So m is what? 5 times 7, 35 over 2. Same thing. Okay, I prefer the second method because it's faster and we're dealing with time in Jamb. Okay, so that is direct variation. That's direct variation. Direct variation, as one function increases, the subsequent function also increases. Okay, let's see inverse variation. Let's see inverse variation. Inverse variation. Now for inverse variation, s varying inversely as y is written this way. This is written as s varying inversely as y. Inverse variation or indirect variation, you must have the inverse sign, 1 over. 1 over means inverse. Okay, so you must have that inverse sign. You must have that inverse sign. S varying inversely as y. What this means is that if you increase s, the corresponding value of y will decrease. Okay, then if you decrease s, the corresponding value of y will increase. Okay, so let's take the first question. It says, if y varies inversely as s squared, how does s vary with y? Okay, so y is varying inversely as s squared. Okay, then if we put our constant sign to replace our proportional sign, y becomes equal to k over x squared. Okay, now how does s vary as y? Making s sort of formula here, we'll be able to know how s varies as y. So if we cross multiply, s squared y is equal to k, meaning that x squared is equal to k over y. I'm trying to make s sort of the formula. To remove square root both sides, s is equal to the square root of k over y, meaning that s is equal to square root k over square root y. So s is equal to, if you square root a constant, you still get a constant. So this is as good as a constant, which you can call p in this case, over root y. So s varies inversely as the square root of y. S varies inversely as the square root of y. Okay, that's how s now relates to y. The next question is asking us to, if s varies inversely as y and s equal to 2 over 3 when y is equal to 9, we're expected to find y when x is equal to 3 over 4. Okay, now looking at this, you see that s is varying inversely as y. So s is varying inversely as y. That's as y, not y squared. Okay, s is varying inversely as y. S is varying inversely as y. Okay, bringing your constant sign, s becomes equal to k over y. Okay, s becomes equals to k over y. Now when S is 2 over 3, y is 9. So let's substitute. When S is 2 over 3, y is 9. So cross multiply. You'll be seeing that k is 2 times 9 over 3. So k is 6. So it therefore means S is equal to 6 over y is our relationship. With this relationship, you can get any other corresponding value of S or y when each of them is given. Okay, so the question answer, you should find y, look for y when S is 3 over 4. So put 3 over 4 here. 3 over 4 is equal to 6 over y. Cross multiplying. 3y is equal to 4 times 6. Y is 4 times 6 over 3. Y is 8. So y is 8 when x is 3 over 4. Okay, the same way, using the second method, from here you see that S is equal to k over y, cross multiplying. You see that k is equal to xy. So we can say x1 y1 is equal to x2 y2 because it will always give you a constant k. Okay, for the first case, when S is 2 over 3 times y is 9, it's going to give you, for the second case, when S is 3 over 4, we should get y. Okay, so we cancel here, we have 3. So 6 is equal to, because 2 times 3 is 6, 3 over 4 times y. Cross multiply. 6 times 4 is equal to 3y. So y is 6 times 4 over 3. So y is 8. Okay, so that's how to solve inverse and direct variations. They are just straightforward. Let me solve one more question under inverse variation. It says if y is inversely proportional to the square root of s, y is inversely proportional to the square root of x, and x is equal to 16 when y is equal to 2, we are now told to find 2, we're told to find 2, find x rather, find x when y is equal to 24. Okay, we have to find x when y is 24. So y varies inversely as the square of x. Y is equal to k over square root of x, square root of x, square root of x. Y varies inversely as square root of x. Okay, then to get constant k, we need to introduce these values. When x is 16, y is 2, so put 2 for y is equal to k over square root of 16. This is 4, so k is what? It means k is 2 times 4, and that is 8. So y is equal to, k now is 8 over square root of x. This is the relationship. Okay, now with the relationship, we can now find s when we are given y to be 24. So put 24 here. 24 is equal to 8 over the root of x. Okay, if you cross multiply, 24 times root x is equal to 8, meaning that root x is equal to 8 over 24. Root x is equal to, this is what? 1 over 3. To get s, and this is square root, to square both sides, s is equal to square here, have 1 over 9. Okay, so s is equal to 1 over 9 when y is equal to 24. Now let's use the second method, going direct. You have, from this point, you see that k is equal to y root x. So it simply means y1 root x1 is equal to y2 root x2. So for the first case, when x is 16, y is 2, so put 2 times root 16, x being 16 is equal to, for the second case, when y is 24, we're looking for x. Okay, so this is 2 times, this is 4 is equal to 24 times root x. This is 8 over 24. 8 divided by this 24 is equal to root x. So root x is equal to 1 over 3. And of course, x is equal to 1 over 9. Same thing. Okay. Okay. So direct variation and indirect variation down. Let us go to joint variation. Joint variation. Joint variation. For joint variation, what you should know about joint variation is that number one, it involves more than 2 variables. It involves more than 2 variables. Okay. Then number two is that most of the time the cases combine both direct and indirect proportions. So it combines both direct and indirect proportion, both direct and inverse proportion. Most of the times a combination of these two. Okay. Let's just go straight to an example so I use it to explain to you. It says we're dealing with joint variation now. It says m varies directly as n and inversely as the square of p. If m equals 3, when n equals 2 and p equals 1, find m in terms of n and p. Okay. Now the expression says m varies directly as n. M varies directly as n and inversely as the square of p. At the same time is varying inversely as the square of p. So m is varying directly as n and also varying inversely as the square of p at the same time. Okay, so if we bring equals to, we'll be putting a constant k n over p squared. Okay, now when m is 3, so put 3 here, n is 2, p is 1, we'll be able to get k. So this is 3 is equal to k, n is 2, and p is 1. 1 squared is 1 still. Okay, so you have 3 is equal to 2k over 1, and from here you see that k is equal to 3 over 2. So it means m is equal to, in place of k, I'll put 3 over 2. That this is the relationship. That's the relationship. That's how they relate. Okay, now if this is the relationship, it means that find m in terms of n and p. I've already found m. I've made m in terms of n and p. So that is what they want us to get, and that's what we have gotten. Okay, so joint variation combines direct and indirect variations at those times, and you solve along. Okay, next question. It says if f varies directly, don't forget most of these questions are Jamb questions, as the square of v and inversely with r, when f is equals to 100, it was observed that v is equal to 5 and r is equal to 2. The question is now saying we should find f when v is equal to 8 and r is equal to 4. Okay, so f varies directly as the square of v. S varies directly as the square of v and inversely as r. Okay, so meaning that f is equal to kv squared over r. Now when f is 100, v is 5, so k times 5 squared, r is 2. So I can get k from here. This is 25. Cross multiplying 100 times 2 is equal to 25k, meaning that k is equal to 200 over 25. 200 over 25. 100 times 2 is 200. Okay, so it means from here that if we divide, k is 8. So k is equal to 8. So our relationship now becomes f is equal to k is 8 v squared over r. Okay, so this is our relationship. Now from the relationship I can now get v. I can now get any value, whether v or f or r, when I'm giving the other two. So I want to get f in this case, and I'm giving v and r, So f now becomes 8. V in this case now is 8. So 8 squared, v squared, 8 squared over r, which is 4. So f becomes 8 times 64 over 4. 4 here, 1, 4 here, 16. 8 times 16, it's 128. Okay, joint variation. If you have any question to ask, because I'm not physically there with you, it means you need to come online to get across to me. I am on the various social medias. Just drop a message, ask a question, and I hope to answer. Go to any of the social medias and search through my name. You're going to get across to me. Okay, now for partial variation, which is the fourth kind of variation. Partial variation is variation expressed as a sum of terms. Is variation expressed as a sum of terms. Now, for you to easily remember partial variation, just remember equation of a straight line. M is equal to mx plus c. Okay, now y is equal to mx plus c, y is equal to ms plus c. Y and s are the variables. Okay, y, m, and c are the constants. M and c are the constants. This is the equation of a straight line. When we come to coordinates geometry, we're going to study it better. Okay, y and s are the variables, m and c are always constants. So this is how every partial variation looks like. You have a variable here, a variable inside, and you're going to have two constants in there. Okay, so let us take the first question. It says the cost of maintaining a school is partly constant and partly varies as the number of students in the school. With 50 students, comma, the cost is 15,705 naira. Then with 40 students, the cost is 13,305 naira. It says find the cost when there are 44 students. Okay, find the cost when there are 44 students. Now, the cost of maintaining a school, let's call that C. C represent cost, and the number of students, let's call that N to be number of students. Okay, now you can see partly here, that tells you it is a partial variation. So let's express it. It says the cost C maintained during a school is partly constant and partly varies as the number of students. So C is equal to A plus B N, where this is our first constant and this is our second constant. C is cost, N is variable, because C is partly constant and partly varies as number of students, N. Okay, so this is exactly how it always looks like in partial variation. You always have two constants. It looks this way every time. Okay, now we are now told that when we have 50 students, meaning that when N is 50, cost is what? Cost is 15. That. They were also told that when N is 40, cost is 13,305. Okay, then we're now told to calculate for cost when students, we're now told to calculate for cost when number of students is 44. This is what we should calculate for. Okay, now from what was given to us, these two values given to us, if we substitute it into this, we should be able to get A and B solving simultaneous equations. So let's substitute. When N is 50, C is this. So C is 15,705 is equal to A plus BN. N is 50, so 50B. And if we substitute these values, C in this case is 13,305 is equal to A plus N in this case is 40, so 40B. Okay, so if I call this equation 1 and I call this equation 2 and I solve it simultaneously, is equal to A plus 40B, this being equation 2. I want to solve simultaneously. It means if I subtract here, A is going to cancel A and I'll be left with 10B here is equal to, this is 0, this is 0, this is 4, and this is 2. So it means B is equal to 2,400 over 10, and that is 240. So B is equal to 240. Now, since we have B, we can substitute into equation 1 or equation 2 to get A. If we substitute into equation substitute into, I'm trying to see the easiest one to substitute into 1. I choose 1. For substitute into 1, I'll be having 15705 is equal to A plus 50B. In place of B, I'll put 240. So 15705 is equal to A plus, multiply these two, you'll be getting 10,560. Okay, so taking over A is going to be 15,705 minus 10,560, meaning that A is equal to, substituting here, subtracting here, A is equal to 3,705. Big values, right? It's usual. Okay, so if A is this and B is this, we can substitute it here to get the relationship, meaning that C is equal to A plus BN becomes C is equal to A now is what? 3,705 plus B is what? 240N. Okay, so this is the relationship. This is the relationship. With this relationship, we can now solve for C. We can now solve for C. We can now solve for C when N is 44. So I can get C when I put 44 here. So C becomes 3,705 plus 240 times 44. So C is equal to 3,705 plus um um this times this gives us um this times this gives us 10,000, and that C now becomes, if you add these values, you'll be getting 14,265. Okay, so that's the cost. That's the cost. That's the cost when N is 44. Okay, now I'll take the one that has smaller values so that the values won't be too big, but it's the same process. The same process every time. Is the same process. It's just dealing with the values here. Okay, next question says um in a restaurant in a restaurant in a restaurant, comma, the cost of providing a particular type of food is partly constant and partly inversely proportional to the number of people. Okay, if the cost per head for 100 people is 30k and the cost for 40 people is 60k, find the cost for 50 people. Find the cost for 50 people. Okay, in a restaurant, the cost of providing a particular type of food, let cost be C, is partly constant, partial variation, partly constant, and partly varies inversely proportional to the number. So number of people, let it be N. Let's call that N. Okay, now it means that cost is equal to A plus B. Now we're told that in this case the number of people is, cost is inversely proportional to the number of people, inversely proportional to the number, so this is over N. Inversely proportional, so it has to be 1 over because of this word inversely. Okay, now we're told that if the cost when C is, if the cost per head of 100 people is this, when C is 30, N is 100, okay, and the cost for 40 people when number is 40, C is 16. Okay, so with this we can get the constants A and B. So if we substitute the first case, C being 30 30 is equal to 30 is equal to substituting a plus b over, when c is 30, n is 100, so put 100 here. Multiply through with 100, you have 3000, which is 3000, is equal to 100. 100a plus 100, it cancels b. This is equation 1. Okay, for the second case, when c is 16, a plus b over n is 40. Okay, if you multiply through with 40, you'll be having 2400 is equal to 40a plus b. 40 times this 40, 40 cancels 40, and b is left there. Okay, this is equation 2. That's equation 2. So we have equation 1 and equation 2 to solve. You can solve them simultaneously. We'll be having the constants a and b. Don't forget to have to calculate cost. Find cost when we have n to be 50. But let's get the a and b first. Okay, so equation 1 is 100a plus b is equal to 3000. Is equation 1. And 40a plus b is equal to 2400, and that's equation 2. So looking carefully, if I subtract here these equations, this will cancel off and I'll be left with this minus this is 60a is equal to this minus this is 600, so a is equal to 10. Okay, if we put it into equation 1, we'll be having 100 times a, which is 10, plus b is equal to 3000. This is 1000. Take it over. I have b is equal to 3000 minus 1000, 2000. Okay, so from here, we want to get this relationship now. It means that c is equal to a plus b over n can be written as c is equal to a is what? A is 10 over n plus b is 2000 over n. This is the relationship. That's the relationship. Okay, that's the relationship. With that relationship, we are told to find c when n is 50. We are told to find c when n is 50. So I want to get c, 10 plus 2000 over n now is what? 50. 0 cancel 0. This here is 4, 0. So c is 10 plus 40. So c is equal to 50. This is the pattern. This is always the pattern. This is always the pattern. If you know the pattern, you can always solve it. They won't do anything or give you anything outside the pattern. So solve these questions over and over and over and over until it becomes second nature to you. Just keep solving, keep solving, keep solving, keep solving until it becomes used to you. Okay, now I want to solve some general questions because we have covered the 4 different types of proportions. So I want to solve general questions, and we'll be having a swell time now. Now this question says, if s varies inversely as the cube root of y and x equal to 1 when y is equal to 8, find y when x is equal to 3. Okay, s varies inversely as the cube root of y. S varies inversely as the cube root of y. S varies inversely as the cube root of y, meaning that s is equal to k over the cube root of y. Okay, now, and when s is 1, y is 8. So when s is 1, y is 8. This is the cube root of 8. Cube root of 8 is what? It's 2. So 1 is equal to k over 2. So k is equal to 2. So putting it here, we'll get the relationship to be s is equal to 2, which is now k, over cube root of y. This is the relationship. Okay, that's the relationship. We're now told to find y when s is 3. So if I put 3 here, what is y? 3 is equal to 2 over cube root of y, cross multiply. Cube root of y is equal to 2 over 3. What can I do to remove cube root? You don't forget what cube root means. It means 1 over 3. So to remove cube root, you multiply by 3, a power of 3 here. So if you do that, you also do this here. Okay, so y now is equal to the cube. To remove cube root, you cube the cube of this. 2 cube is 8, 3 cube is 27. So y is that. Okay, next question says it's becoming more interesting now. S is directly proportional to y and inversely proportional to z. If S is equal to 9 when y is equal to 24 and z is equal to 8, what is the value of S when y is equal to 5 and z is equal to 6? Okay, so S is directly proportional to y and also inversely proportional to z. So this is a joint variation, okay, directly and inversely. So from here I'll say S is equal to k y over z, removing proportional, putting equal to. Now when S is 9, y is 24, so I have k times 24 and z is 8. So from here k is equal to 9 times 8 over 24. This here 1, this here 3, 3 here 1, 3 here 3, so k is 3. So if k is 3, it means S is equal to k is 3, 3y over z. This is the relationship. Okay, since I now have the relationship, I can look for S. The question says what is S? I'm looking for S when y is 5 and z is 6. So S is equal to 3 times y is 5 and z is 6. This is 2, so x equal to 5 over 2, 2 whole number 1 over 2. Okay, now this next question is demanding that if S is jointly, okay, in this case it was stated as jointly, so your mind should go to jointly proportional to the cube of y and the fourth power of z. In what ratio is S increased or decreased when y is halved and z is doubled? Okay, S is jointly proportional to the cube of y and the fourth power of z. So x is equal to y raised to power 3, z raised to power 4. So in what ratio, when you now have a new S, is S increased when you increase S, or decreased, we don't know what it will be, such that if y is halved and z doubled, how will it affect S? So the new S, let's call it the new S, such that when you halve y, so you want to have this y to be y over 2, which is halved now. So y now is y over 2 raised to power 3. Then z is doubled. So you have z, 2z, z is now 2z raised to power 4. So the new s will now be y over 8 times, this is 16z. This cancels, we're left with 2. So the new s, it will be 2y raised to power 3. Y raised to power 3, if you, this raised to power 3 is this raised to power 3 is this raised to power 4 is, there should be 4 there. So y raised to power 3, 0 raised to power 4. Okay? Okay? Now, the ratio with which this z goes to this, it's the new z over the old z is going to be, new z is 2 y raised to power 3, 0 raised to power 4 over y raised to power 3, 0 raised to power 4. This cancels this cancels this, so you have 2 over 1, which is 2 ratio 1. So this is the ratio, and as you can see, it increased by 2. So it increased by 2. Okay. The next question is saying if w varies inversely as v and u varies directly as w cube, find the relationship between u and v given that u is equal to 1 when v is equal to 2. Okay, now if you look very well, w varies inversely as v. Okay, then u now varies directly as w cube. We're now asked to find a relationship between u and v. Now, if you look at this relationship, it's between u and w. This is between w and v. Okay? Now, you want to get a relationship that has u and v. So, it means you need to eliminate w. Okay? Now, from here, you see that w can be represented with 1 over v. So, in place of w here, I can simply put 1 over v. So, it means u is directly proportional to, in place of w, I can put 1 over v raised to power 3. Just remove w and put v so that you have a relationship that has u and v. So it means u is directly proportional to 1 over v raised to power 3. Okay, now bringing your constant sign, u is equal to k over v raised to power 3. We want to get k when u is 1, v is 2. So when u is 1, put it here, 1 is equal to k over v is 2, 2 raised to power 3 is 8. So k is equal to 8. So the relationship is u is equal to 8 over v raised to power 3. That's the relationship. It says find the relationship between u and v. Okay, so that's the relationship. Next question says if p varies inversely as v and v varies directly as r squared, find the relationship between p and r given that r is equal to 7 and p is equal to 2. Right. Please write along as I take the questions. Write along. Okay, so p varies inversely as v, and v varies directly as r squared. P varies inversely as v r squared. Find the relationship between p and r. So we want to combine p and r. Now, if you look critically here, to combine P and R, we need to represent what V is. Okay, now if you look here, V is equal to R squared. So in place of this V, I can put R squared. So P is proportional to 1 over, in place of V, R squared. Now this relationship is now having P and R together. Okay, so you have to look at the equation to substitute in, just to make it to eliminate one of them. Okay, so it means P is equal to K over R squared. Now when R is 7, P is 2, so 2 is equal to K over 7 squared, which is 2 is equal to K over 49. K becomes what? 2 times 49, and K becomes what? 98. So the relationship becomes P is equal to 98, which is K over R squared. Okay, very good, very good, very good. Okay, the next question is saying if y varies inversely as x squared and x varies directly as z squared, find the relationship between y and z if c is a constant. The constant in this case is they're asking us to use constant c, not constant k, to get that. Okay, so y varies inversely as s squared and s varies directly as z squared. We want to get a relationship between y and z. So we want to get a relationship between this and this, meaning we need to remove s. Now you see here s equal to this, so I can put that here. Y is proportional to, in place of s now, I put z squared. S is z squared, then this squared for s. So s is this and that. So y is proportional to 0 raised to power 4, meaning that y is equal to k over 0 raised to power 4. So this is the relationship between y and z. Now the constant now is not k but c. So y is equal to, in place of this constant, I put c and this. Okay. Okay, I think we have 2 more questions to go, and after that we'll be through. So hang on. Let me carefully select the next 2 questions. This question says if s varies inversely as y and y varies directly as the square root of z, and z varies directly as 1 over w squared, write down in words how s varies with w. Okay, so s varies inversely as y. Okay, y varies directly as the square root of z. Okay, and z now varies directly as this. Now I want to write down in words the relationship between s and w. So I want to relate this to this. Okay, want to relate that to that. Now you follow this in order. You substitute w here, so you have x and z. you now substitute z to have x and w. So we'll take these two first. Y here is square root of z, so I can put that here, meaning that s is proportional to 1 over, in place of y you can put square root of z, okay, and z is this, so it means in place of z here I can put square root z is this, 1 over w squared. Okay, so I can say s now is proportional to 1 over, if you find the square root of this, you'll be having 1 over w. 1 over that is going to flip to give you w. So s is directly proportional to w. In words, s is directly proportional to w. Okay. Um. Um. Let me see if I have any very much more interesting question for you. Oh, okay. Let me just do this with you. Let me do this with you. It says s varies inversely as the square root of y if s is equal to 1 when y is equal to 1 over 4. Find y when s is equal to 1 over 6. So s varies inversely as the square root of y, okay, meaning that s is equal to k over root y. So what is k? K is equal to s root y, meaning that s1 root y1 is equal to s2 root y2. So when s is 1, put it here, y is 1 over 4. We are to find y when s is 1 over 6. Okay, 1 times this is going to give you 1 times this is going to give you root of 1 over 4 is 1 over 2. It's equal to 1 over 6 times root y. So this goes here to give you 6 over 2 is equal to root y. Root y is equal to 3, meaning that y is equal to 9. Okay, so this is the length, breadth, and height of variation. If you have any question, any question, please get across to me and I'm going to help you handle that. Thank you once more for the time, and don't forget to read and read and read and read.